Well, good morning, everyone. I'm Jeff Puma, Content Director for the Manufacturing Leadership Council, and I'm excited to have you all here today for this Automation and Operational Excellence Decision Compass call. We'll be talking about vision system strategy considerations, so things you need to think about as you consider building out a strategy around vision systems. So the ideas you need to have in mind, the all of the different elements that need to come into play there. And I'm excited to be joined by some of our friends over at Clarios for this call. Um, the agenda for today, we'll do a few MLC announcements. Then there'll be the presentation, and at the end, we'll have Q&A. And then finally wrap up with a little bit more of a rehashing of some of the things you heard earlier in the call. As far as Q&A is concerned, what we'd love is if you could leave your cameras off and your microphones on mute for the content portion of the call. And if you do have questions that come up throughout, put them into the chat so we have those queued up and ready to go at the end. That gives us a little bit of a cleaner recording and a better flow to the call. So cue them up, and at the end, we'll ask you if you want to come off camera or come on camera and come off mute. You can ask that question live, especially if there's some nuance to your question that's very helpful. But cue those up as we go through. So let's talk about a couple of things that are upcoming for the MLC that are important for you to be aware of. So first up, rethink. We are ahead of the game as far as registrations are concerned. We generally sell out, and this is the premier event for us, so you don't want to miss it. And because we're already ahead of our registration pace from last year, I would recommend registering earlier than waiting. Just because, like I said, we're ahead of where we were last year at this point. It always sells out, so get in there and register now because you don't want to miss it. We have incredible case studies from folks like Hershey's and IPG. We have folks from Goldman Sachs and Siemens and Calypso and Rockwell and all these great companies coming in to give presentations. Plus, the networking is second to none. Just the ability to rub elbows and pick the brain of people going through the exact same thing that you are as far as digital transformation, it's invaluable. So highly recommend that you register for Rethink as early as possible. There's a link in the chat as well as a QR code on the screen. Next up, upcoming plant tours. So we have both Schneider Electric and United Scrap already announced and open for registration now. That QR code will take you to the tours page. I made it green because both Schneider and United Scrap Metal have green in their logos. So I thought it would also be a little bit festive since we're in the week of St. Patrick's Day. So go to our plant tour page and you will see registration for both of those. Schneider may have one or two registrations still available, but you may be waitlisted at this point in time. And I would still recommend if you are interested to sign up for that wait list because if something opens up, we will pull from that list. And United Scrap is in August and right outside of Chicago, and it should be an incredible tour as well. We do have a survey that is open right now. That is our Future of Manufacturing project survey. For those of you who have taken our surveys in the past, you know that the Future of Manufacturing project survey, or formerly the Manufacturing 2030 survey, is a big one. It not in terms of how much time it takes you to complete it, but in terms of the output that comes from it. We do a super deep dive into the data that we get from this survey. We create a survey report that's blown out and just incredible content, pulling in trends and other sources beyond just what we get in that survey. It is a big deal for the industry. It has a lot of incredible details that come out in that survey report. And so I highly recommend you take that survey. There's a QR code on your screen to do that. We'll be closing that tomorrow. So you want to have your voice heard, you have to go take that today. So, all right, so let's move back towards the DC call information. So, as you all know, we merged the Automation Consortium and the Operational Excellence DC group this year into one cohesive group because there is so much overlap. We talked about autonomous optimization in manufacturing in our last call. That recording is available in the member portal. And so I would recommend that you go and check that out when you get a chance. Today we'll be talking about vision system strategy. And here are the rest of the dates for our year. Before I hand it over to Joe and Tobias, I want to remind folks that you can put your questions into the chat as we go through the presentation. And if you could leave your camera off and your microphone on mute until we get to that Q&A portion, that will help us get a clean recording. Joe and Tobias, I am going to stop my share and you can share your screens and we will go from there. So thank you for being here with us today and excited about this presentation.
Thank you very much, Jeff. Good morning, good afternoon, good evening, everyone. Can you hear me all right?
Yes.
Yes, we can.
Perfect. That's awesome. So welcome to our presentation on computer vision systems and some strategy development considerations. Today, we'd like to share with you our journey that we have started around 18 months ago, take you a little bit along the history and foundations and basic principles of vision systems, how they have developed in the last couple of years, and how we are applying them today, what we see for the future, and what we have learned are the key elements that need to be considered for building a vision system strategy for the company. My name is Tobias Kuptz. I lead the global manufacturing engineering for Clarios, and at around the half of the presentation, I'll hand over to Joe Schermerhorn, who's on my team and leads our automation and smart manufacturing. So once more, welcome. Before we look at the vision systems, very quick introduction to Clarios. Who are we? Clarios is the global leader in automotive batteries. We have an amazing footprint. We are represented in 4 continents of the world, from Asia, over Europe and the Middle East to North and South America. We are the #1 market leader and approximately 4 times the size of our closest competitor. You will find our batteries in 1 out of 3 vehicles. So chances are very high that your vehicle is started in the morning by one of our batteries. We're selling around 150 million automotive batteries per year. And we are supplying more than 100 countries, primarily 80% in the aftermarket. So our business is OE, but has the resilience of aftermarket. We are very, very proud that 100% of our products are recyclable, and we recycle a lot of them in-house. And we have a tradition of more than 130 years making batteries and innovating and growing. Some of our main brands that you might have heard of are Varda, LTH, Delcor, Heliar, Optima, and Mac. We have around 17,000 associates globally. So much about Clarios. Now let's take a look at vision systems. When we started looking at vision systems and what we can do with them, we realized that computer vision systems will revolutionize industrial manufacturing. They'll enable fully autonomous production lines and drastically reduce errors and significantly increase efficiency. We learned that going to fairs, doing benchmarking, trying to understand what does the future of manufacturing look like. And okay, you might now ask, why do we need a strategy for that? Why don't we just implement and learn? Well, this is the point why we are sharing this with you today. We have come to the conclusion that a strategic approach ensures scalable solutions that enable faster rollout and standardized processes. We believe that companies that strategically implement computer vision technology will enhance operational efficiency and lower production costs, increasing the flexibility and improving quality faster than others. And this will position those companies as leaders in innovation and competitiveness. That was our key takeaway that led us to we have to become strategic on vision systems. We are right in the middle of this approach, so we're not done. We're still learning, but I'd like to, while the memories are fresh, share those with you here. Before we look into what is a vision system, a very, very brief history on a page. And I personally found it very interesting when we started researching that the first vision systems where a camera got attached to a computer came up in the mid 60s. Then in the 1970s, the first image processing techniques were implemented, and in the 1980s, contour models generated out of pictures came up for the very first time. In the 90s, camera calibration and 3D reconstruction through stereo correspondence and image segmentation were developed. And while this is still pretty abstract, in the 2000s, for the very first time, something came up that we all have heard of and we all use today, namely autonomous vehicles, at least to a certain degree, and facial recognitions, right? We all have it on our mobile devices today. Then the 2010s brought more software capabilities to vision system technology, including deep neural networks, convolutional neural networks, and object recognition and localization. Especially the latter is very, very important. We will look at the future of vision systems on one of the later slides in the deck. So hang on. Before we do that, I'd like to add two more slides on what are vision systems and how can we classify them. This is important to understand because when you're planning a vision system, you want to pick the right system for what you're trying to achieve. If we try to divide them into two basic categories, there are 3D or point cloud systems and there are 2D image systems. The 3D systems work in two different ways. You can either have a laser scanner, probably heard the term LiDAR, used in cars, used in mobile phones, the more advanced ones. We have an actual laser scanner, scan and create a point cloud by measuring the distance between the scanning device and the objects. And what you can see in that little picture down there is a picture of a church in Germany, probably, that has been taken with a LiDAR or a laser by using a drone. And then there's the very interesting technology of pattern projection, where you are projecting a pattern onto an object, typically a stripe pattern, of sharing, of changing width and direction. And depending on how this image changes and the shadows, the software then creates a 3D image and again a point cloud using a conventional camera and this pattern projection technology. In the end, in any case, what you end up with is a 3D model represented by a point cloud. Then there are 2D image systems represented by this facial recognition image in the bottom. That is a flat 2D image where basically points in this plane are measured and compared. There can be image analysis, there can be video analysis, and the analysis could also be made using non-visible light. So there are systems using infrared, ultraviolet, and X-ray imaging. So all that is part of vision systems, but those are the two basic classifications. There's one thing that all vision systems have in common. That is the basic working principle. All vision systems are based on the concept of creating a contrast image and using software-based evaluation, trying to make it as easy as possible. Every system, we'll take a quick look at the components on the next slide, has two key functions or two key features. One is the image capturing, depending on camera resolution, the lens, the lighting, very, very important. And the second main point is a contrast-based software. This could either be rule-based, which was the case especially in the earlier years, and lately we have contrast-based analysis using AI dominate the market or taking over a lot of the functions that previously were rule-based. One thing that all systems have in common is that it is all about a pixel contrast comparison, as you can see in this slide here. So here on this page, we have a simple summary of the components of a vision system. And this will be important later on when we talk about standardization and strategy. So the objective for each vision system is to take a real-world object, capture the image, process the image to create a digital model, then do something with model. So coming from the object through the system, we have the following main components. We start with the lighting. Lighting is important because we are typically dealing with visible light. It's important to control that to create the right contrast, right? We just learned everything is contrast based and we want to minimize shadows. Then we have the optics or the lens with a defined working distance, field of view, depth of the field, which typically is application specific. Then we have the sensor. The sensor is the part that has the megapixels between 1 and many, many megapixels. That is the part in your device that actually captures the image, typically CCD or CMOS sensors that do that. All that is nowadays mostly combined into what we call the camera. So you see in this little picture, this camera here has a circular lighting module. And you see a lens, and the CCD chip is hidden inside the camera. So the image is captured in those, and often it's also processed or pre-processed. For that, the devices or the systems use an image processing software that does this pixel contrast comparison that we've looked at on the previous slide. So this is what turns the real world or the picture of the real world object into a digital model, and then an interface, and also typically standardized today, HTTPS, using Ethernet, transferring that to whatever system we want to have it transferred to, a database or a PLC. So this is the high level components and working principle of most of the vision systems that we use today. So In order to understand what is important for a vision system strategy, we need to understand what has kept us from a widespread implementation and standardization of vision systems in the past. Because when I talk to people, very often I heard, oh, we've tried that 5 years ago. We've tried that 7 years ago. Yeah, it doesn't work. Yeah, it's too slow. Yeah, you need a lot of resources to support vision systems. For every two vision systems that you implement, you need at least one person taking care of them, which actually it was true in the past. The systems were struggling with glare and reflection, leading to an unstable contrast image. So in the past, typically you could see that there was a huge box around it that prevented light from the outside getting into the system. Also, they required large annotated data sets, meaning training data, images that were categorized in good, in bad, and um, that could be a very labor intensive process. Also, deep models required high computational capacities, which were very expensive. Still, the models lacked fairness, and they had a significant amount of interpretability. It was very difficult to program two vision systems in the same way and reach the same result. So they were not a really good judge whether something was good or something was bad. And there was a lack of standardization across hardware and especially software. So that led to the impact that I briefly described. It was very labor intensive. And since the training and the optimization of the system had to continue over an extended period of time, it was usually preferred that the integrator who developed the system, who together the camera hardware, the lens, the lighting, and the software, those were at that time were typically individual components. You wanted those specialized companies nearby. Typically, those were relatively small businesses, only able to support locally. Then again, the training, the maintenance, the retraining when you needed to bring additional products that the system should be covering, that was a time-consuming process. And due to the significant computational power needed, there were typically standalone computers which may or may not have been connected to the network, may or may not have been company standard. All in all, that led to isolated solutions with a very limited scalability. So this is important to understand. Why has nobody really invested a lot of time and looked into a strategy for vision systems? Well, many of those things that led to this very local approach have changed in the meantime. So special lighting technologies have helped to significantly reduce the sensitivity to glare and reflection. So we now have a better, more stable contrast image than in the past. Efficient algorithms and better hardware have significantly improved the speed of the picture analysis. Now the decision making doesn't take seconds anymore, but it takes milliseconds. Edge computing has further improved the speed, it has minimized latencies, and has significantly reduced the computational resources. So modern systems typically don't require a standalone PC anymore for the picture analysis. And also, along with that, we've seen a more standardized hardware and software portfolio, which are easier to integrate and support. So more major brands have a full lineup of standardized cameras, lenses, lighting, and software, which makes it easier to have a toolkit built or use standard solutions for most use cases. This now enables us to consider a more holistic strategy. First of all, it brings the costs down very significantly because modern systems are much, much easier to train than systems in the past. While the programming in the past was a lot of coding, many systems nowadays are low code, no code. Already mentioned, the processing is almost real time. Decision making is very fast. And there are huge libraries of standard applications that allow you to program a simple task within uh, minutes or a couple of hours that in the past took days or even weeks. All in all, this advancement made in the hardware and especially in the software, along with the standardization that the market has seen and those toolkits that are now available, those enable scalability. Um, with that, we can start building more or less of a standard toolkit to address our computer vision needs. Yeah, and with that, I'm handing over to Joe. Joe, can you take it from here, please?
Perfect, thank you. And is this the version where we will be able to show the video?
I hope so.
I hope so. Perfect. So this is an example, a real world use case that came out of Clarios, and this is in our Toledo facility. What you see here is a depalletizing, or what we would call a stack-on robot cell in our Toledo plant. The robot comes equipped with a fully integrated 3D camera for picking and placing. In this case, we're picking and placing batteries, fully formed or dry unformed batteries onto our formation line. So you can see the robot has the end effector to be able to pick and place the battery from the pallet onto the conveyor. It also has the ability with the end effector to remove the slip sheet and place that in the pile in between each layer. So we used an integrator to install and commission this robot cell back in 2022. The integrator we chose was very knowledgeable and experienced, and we had a great experience with that integrator, and they've proven to be a good long-term partner for Clarios. So just another pro tip is, make sure you do your due diligence when choosing your integrator after you have your design identified for your project. So the camera used for this application has a somewhat limited ability to recognize a change in position or orientation of the batteries. So it is present. We are using a vision system, but back in 2022, it's not as advanced as what we could have used. So with that in mind, because this project has been successful, we do have a planned future installation in 2025, the year we're in, to include a camera that includes more advanced bin picking technology. So when we talk about bin picking technology, it has a little bit more flexibility and a higher tolerance, so to speak, to allow the robot to pick and place batteries from a larger range of deviations, varying orientations, and varying locations on the pallet. So it just gives us a wider tolerance of what the robot will be able to accept when it comes to moving the batteries. So our future outlook as we continue to move forward with vision and AI and machine learning and vision systems, we know that AI and machine learning will continue to enhance vision system capabilities. So it's exciting to see things that are possible now that were not possible even 6 months ago. So it's an exciting world, an exciting time to be alive, as we say. The increased use of 3D vision for accurate measurements and inspections is something that's high on our list. So not just pick and place robotics, but also vision inspection is very important to us when it comes to inspecting the quality of our products. Greater integration with IoT and Industry 4.0 technologies. I think this is a given because vision is becoming more and more, it's creeping into every single aspect of every process that we do today. So it's slowly getting there, and obviously we were able to rack and stack and prioritize where vision makes the most sense and where we want to place our focus first and second and third and so on. But it definitely seems to be very far-reaching within our company. Some of the strategic benefits of AI and machine learning are the vision systems will continue to adapt and expand their capabilities, becoming more versatile, more efficient. So I think we've kind of talked about this, but it's exciting to see what capabilities exist today that just didn't exist a few years ago. And the robot that we're installing later this year in Toledo is going to be more advanced and more efficient than the robot we installed back in 2022. These next two bullet points really marry together well. So emerging technologies like AR, VR, XR will further enhance the capabilities of vision systems. We're experimenting that in some of our maintenance tasks that we're looking at today. And with that, AI and ML, excuse me, enable predictive maintenance, real-time decision-making, and continuous improvement. So in some cases, we're thinking of predictive maintenance, preventative maintenance. In other cases, it's real-time maintenance where a line's down and we need AI or ML to help assist us in getting that line back up in a timely manner. It becomes even more critical when you think about the workforce today and the constant rate of turnover that we have, and bringing in new employees and asking them to have this very advanced skill set. We can use AI and ML to give them a boost and accelerate their learnings and accelerate their knowledge and expand their knowledge of our equipment through the use of AI and ML when it comes to fixing and correcting issues on the line. And then finally, the last bullet point is AI and ML can also help identify patterns and anomalies, optimizing production processes and reducing errors. So I recently came across a company that's doing just this. A lot of times when we think about vision inspection systems, we're thinking about inspecting a single component or a single manufactured item, and it's more of a binary check. Is it within tolerance? Is it within standard? Yes or no? A more advanced version of that is if we're looking at every single piece of product going down the line and doing 100% inspection, you can use the knowledge of the previous item to determine, is there a trend happening? So maybe your first item is inspect, your second item produced during that day is inspect, but now it's 1% defective outside of top, maybe within your tolerance, but 1% off. And maybe your third item of the day is now 2 to 3%. Now you're able to identify a trend. If you've got 2 or 3 or 4 data points, you're able to identify trend and trend analysis, and you get into statistical process control. So just one more area where vision inspection continues to expand and grow in what its capabilities are. The vision system slide. So these are what we recognize and discuss as our main components of vision systems. We believe there will be evolution in each one of these components individually. So when we talk about the lighting, understanding how that can evolve and grow, the optics and the lens, and the field of view and the camera system itself. Within the sensors, the CCD or the CMOS sensors obviously have room to grow. The CMOS is generally considered to be the fastest of the two. So when you're looking for a speedier result with your sensor analysis, that would be the CMOS sensor, and then the CCD has a higher degree of quality or a higher degree of resolution in the picture. So both of them have their advantages. It'll be exciting to see those two compete in the years to come. I think where the real excitement is going to be in the interfaces and the camera and the image processing software. So we're paying close attention to that, is how quickly can we process the image, what type of results are we able to get with that processing, and how are we able to get that to do a better inspection for our objects and our batteries that we want to inspect. So really it's about taking that real world object and creating that digital model. It's something Tobias talked about earlier with LiDAR. And then the scalability, the integration, the standardization, the innovation, and the efficiency, obviously all a part of this when it comes to vision systems. So different approaches, and these are all, not all, but most of these are approaches we've taken within Clarios in the last few years. So we started with number 1 on the left, where we did not have any kind of standardization in terms of our approach. It was very opportunistic. The advantage of that is highly flexible, and we're able to utilize nearby service providers. The limitation or the con or the drawback from that is it's limited in scalability. It becomes very complex, and you're going to use a different model for the same test. So that's where we were. We quickly, maybe not so quickly, learned that that's not what the final approach was going to be. So we kind of migrated to approach number 2 about a year ago. And this is where we said, well, let's get the other end of the spectrum. Let's have a standardized approach from a single source. We know it's going to be highly scalable, it's going to be minimal complexity, and we'll have a very commercial advantage because we'll be able to drive down that price. The drawback of that is a lot of times you're not going to be able to find one vendor, one integrator that can cover all your use cases with all the solutions that you needed to have provided. So it's nice to have that one-stop shopping. It makes things simpler on some ends, but certainly drawbacks on the other end. So we have now migrated away from approach number 2, and we're using approach number 3, which is where we want to have a standardized camera and a standardized third-party software. So now we're going back to being more flexible, but not as flexible as we were in approach number 1, where everything was on the table, because we would still like to have a standardized camera and a standardized third-party software. It can be more complex to be able to marry those two together in some cases, because you'll find integrators that don't want to use a certain camera, or they can see advantages to using their camera, and tries to lead you back to approach number 2. But you can create a standardized use case with specific solutions that are highly scalable, and that's where we see the advantage for us at Clarios. There is a fourth option that I don't think we're considering today, but we know it exists, and we've seen others do this and become very successful with it. And that's having a standardized camera and a self-developed software. So if your solution or your problem that you're trying to solve is highly specialized, and you're going to need a high degree of innovation and a high degree of specialization, this could be the right fit for you. There are potential breakthroughs and cost advantages if your solution is unique enough that you require homegrown software. The cons are it's a significant investment, so you got to make sure that your specialized solution requires a significant investment to be able to benefit from a very significant return. I would say that the companies that I've seen do this well are the ones that ultimately monetize this. So they create this in-house, they use it for themselves, they benefit, they take an iterative approach to kind of refining the software and making it work for many, many customers in their industry and outside their industry. So can be exciting to develop something yourself. It's certainly a lot of fun, especially if you're into programming and you have that large enough team to be able to do that. But I think ultimately, to be able to justify something that high of an investment in terms of cost, you really need to be able to sell it to be able to get your payback on that. And now we're moving into what our recommended approach is. So this is sorry, I'm just moving my screen around here. 5-phase approach that we've developed. So phase 1 is what we call strategic planning. So this is where we're going to analyze the size of the prize. So this is conducting an analysis of all the potential benefits and the ROIs for implementing computer vision technology in your manufacturing processes. This allows for informed decision making and prioritization of resources. And then step 2 is prioritizing your computer vision strategy within your company. So integrating computer vision technology into your company's strategic goals and objectives, ensuring it receives the necessary attention and resources. We start talking about dedicating resources, creating a roadmap for the future, what items are going to be on that roadmap, how do we prioritize those items, how do we focus our efforts and our resources to be able to achieve our goals. And that leads us to phase 2. How are we doing on timing?
I think we're doing okay.
Great. So organizational preparation. So this is where we want to structure the organization in a way that's going to allow us to be successful in the future. So we want to establish a dedicated team of specialized individuals responsible for driving computer vision initiatives, including experts in technology. And it's important to make sure this is a cross-functional team. So it's not just technology, but we also want to look at project management, operations. That way we're attacking this jointly and we have buy-in from all the necessary departments to make the initiative successful. This centralized hub of expertise and dedicated resources allows for an accelerated development and deployment of computer vision solutions. And it helps to create that culture that you want in terms of innovation, where we talk about failing fast and fixing it, and being able to iterate quickly with a large group of people. Assessing the organizational needs, identifying opportunities for vision systems. So again, it's conducting a comprehensive assessment of your manufacturing processes from end to end. And you want to identify the specific use cases for computer vision. So maybe that's an inspection of a raw material on the inbound side. Maybe it's an inspection of a finished good before it goes out the door. Certainly, I think in all of our manufacturing processes, plenty of different use cases, and all of them will look a little different in terms of speed and quality and what needs to be inspected at each point. So gathering that list and understanding what that list looks like, and then aligning that internally is very critical to make sure that you have the buy-in from your cross-functional team. And then you want to be able to summarize that list, make sure it gets prioritized within your team, so everyone's aligned on what the North Star is, where are we targeting, where do we want to focus our time and energy and resources. And then phase 3 is our evaluation and selection. So this is where we evaluate key factors and preliminarily select our strategic approach. So we want to understand how scalable is one solution for another. What about the intellectual property? Are we developing this in-house? Are we outsourcing this to a third party? And we want to be able to pull all those different capabilities in to make sure it aligns with our strategic approach. We say a well-informed strategy that addresses key considerations and mitigates potential risk will increase the likelihood of success. So it's really worth setting the table up front to be able to make sure you have the long-term sustainability of the computer vision projects that you're working on. We want to identify preferred vendors for hardware and software and integration. So that's something we're in the process of doing at Clarios today, is selecting the vendors and partners based on their ability to meet our needs. We want to make sure we do our job in terms of laying out what the problems are that we're trying to solve, and then they need to do their job to kind of lay out what their capabilities are and showcase what abilities they have to help solve our problems. So it's an exciting time to understand, what are the different capabilities of the different companies and what are the different approaches. In doing so, you're going to build strong partnerships with reliable vendors and integrators who can deliver high quality solutions and will support the integration of computer vision technology in your manufacturing processes efficiently and at scale. I realize everybody on this call probably has a different level of scale, a few plants to many plants across the globe. Again, your considerations and your approach might be a little different based on your scale and size. And that leads us to phase 4, which is implementation. So select and execute valuable proof of concepts from your catalog of opportunities with chosen partners. So now that we've identified all the solutions, we've kind of racked and stacked which ones are the highest priority and lowest priority. We want to be able to choose which one we want to start our work on and which one we want to start our proof of concept on. So at this phase, we would go out and implement our proof of concept to validate the feasibility and the effectiveness of the solution. If we are able to demonstrate the value and the impact of the vision technology, it'll provide a basis for broader employment. And then again, I mentioned this earlier, but we choose to do a test and learn iterative approach. So we know we're not going to be we hope to be successful the first time out of the gate, but the reality is, with this being new technology and new capabilities that we're introducing into our company, we know that we need to have this fail fast, fix it, and try again approach. So we want to continue to build confidence in the team, build confidence in our leadership, and the potential of the technology to drive significant improvements in manufacturing operations. And as we achieve that, that leads us to phase 5, which is probably the most critical phase of the 5-stage process, and where you get your biggest benefit, which is scaling and collaboration. So scaling your catalog of proven solutions and sharing them within the company to foster innovation and efficiency. In our case, we're a global company, so we put a big emphasis on making sure that the learnings make their way from the US to EMEA and China, LATAM, Mexico, and so on and so forth. So it's not just an isolated learning that only the US or EMEA gets to take advantage of. We can share that knowledge and make sure that everyone gets to benefit from that knowledge. So this is where we would want to scale up the pace of our proof of concepts and share the best practices across the organization. And we also want to promote and start to build that culture of collaboration, experimentation, sharing, and standardization. So all these are very critical, but again, we talked about collaboration between the regions, experimentation, and sharing those learnings. But at the end of the day, you still want to have a standardized approach, because that's going to allow you to have a more rapid deployment. So dream big, start small, act now. I believe that might be our last slide.
That was excellent, gentlemen. Very informative. Loved everything that you were sharing there with the 5-step process at the end, especially. But I think it was really well done presentation, the way that you set it up, the background of it and everything. So thank you for sharing all of those insights and your experiences that you're going through at Clarios. if anyone has any questions that they'd like to ask, I'd invite you to add them into the chat. You'll see a little note there from David Van Engel requesting that. And then we can have you come off mute as well. And you can ask your question live if you would like. And if you're in a spot where you can do that, I know some folks are sometimes in the airport or in a big office that's busy or on the shop floor. So any questions that anyone has that they would like to ask at this point?
Jeff, while people are thinking about that, Joe and Tobias, first off, thank you. This was fantastic. I wanted to ask about, camera technology is just constantly getting better and better and better. And so going back to your example of you built that in the Toledo site, that robot in 2022, and now it's 3 years later and you have to upgrade it, right? And so I'm wondering about, like, as the tools and technology, are you building that in as well? Like, what are your thoughts and considerations of, the technology is going to advance. We would like to quickly implement the latest and greatest into this.
Yeah, so very timely question, because I had this conversation with another engineer in the company in the last week, and we talked about one camera company having AI built into their camera, and another camera integrator saying, you know what, we don't necessarily agree that the right approach is to build in your AI, because the advancements in AI are going to be coming fast and furious in the next few years. So we'd rather have just a straight camera approach, and then use the AI as a separate entity, and have the camera feed into the AI instead of having it all in one. So you're less likely to have your product discontinued. It makes it easier to service if you have those separate components in the short term. And that's starting to be our approach. We're gaining alignment on that within the organization now.
Yeah, I would like to take the question from the chat here. What benefits with vision systems have accrued to Clarios? Can we quantify uptime, productivity, cost? With some of the systems that we have implemented, we were able to automate a process that for the very first time. This robot cell that we shared in this video, what makes this so special is that the product gets to this robot cell not in a standardized stacked way. We stack them manually, so we cannot ensure that a certain pattern is always followed and always exact. So when you look at a traditional robot system, that's a mechatronic system that goes to a certain position and then it does something. It is non-intelligent. With a camera, with a combination of robot and a camera, you turn it into a vision-guided robot and it acts like a real human. It detects the object, and it doesn't really matter with the latest systems where the object is on the palette, even if it sits at an angle or at any position within the operating range. It detects it, it goes there, it picks it, and it puts it onto a conveyor. So you can automate tasks that were completely impossible before. So if your reason why you have not automated a task is that your parts lie randomly in a tote, bin picking technology may be your solution. We've seen robots pick pipe fittings from a tote, and they were just loosely tossed into that tote. You can eliminate dunnage. This is just the benefit of the bin picking technology. We have replaced manual inspections in the line where every battery was looked at by an operator and 80–90% were okay and passed on. And now it is a deviation-based type of job where probably only 10% of the batteries get rejected and get looked at by a human. With that, we are freeing up 50% of his time for value-adding activities. I think those are the biggest impacts, and we are constantly looking at what are the types of measurements that we can turn from tactile physical measurement with gauges to a non-contact measurement, because this allows for a push button changeover, or even zero push button changeover. If you have a unique identifier QR code on the part, there's no need for a changeover. So there are so many benefits with those systems. You have to look at what tests you have in your line, product tests, what manual inspections you have in the line, and where can you enhance the capabilities of a robot with the camera, making it much more precise, much more versatile. And we started building a list 18 months ago. We had 5 projects or 5 opportunities for vision systems on that list, and within 4 weeks, I think we had 20. We keep getting more every month, where some of our plants start experimenting with technology for various reasons. Some are customer requests, and possibilities are almost endless. As long as you follow a certain level of standardization, this immediately can become a solution that any plant in the network can deploy. If you have one hub where you collect all those solutions, they're all somewhat standardized. It's a one for all development type. And to comment really quickly on the adoption, if the system is well made and functioning and making people's life easier, adoption is great. If the system becomes a nightmare because it's difficult to work with, there is no adoption.
Yeah, we've seen that before with systems that have too many false positives or false negatives. That, again, operations is a critical part of the cross-functional team, and they do not appreciate having to analyze more rejects than what they would normally analyze. The systems malfunction, or if they're just not robust enough for our needs. So,
okay, so that was Shrag's question. Nate, I see a question in the chat from you. Are you in a spot where you can come off and ask that?
Yeah, sure. Yeah, sure thing. So, I mean, you guys spoke a little bit about the different options, and I find that there's a lot of options out there in the market, right? So there's many vendors that are doing computer vision. There's lots of hardware options. There's cloud computing technologies. I guess, could you guys share a little bit more around kind of it? It sounds like you've developed some of it yourself, like that make versus buy and what goes into that decision. Then kind of like separate from that, how do you drive towards standardization? Because we often bounce into personal identifiable information, security, things around KPIs for model drift, things like that. So if you could share a little bit in that space, it'd be helpful.
Joe, do you want to take this?
sure. So when it comes to make versus buy, you're right. I think we talked about that earlier. That's a strategic decision within the company. And what we're seeing out there from the vendors far exceeds where we're able to produce in terms of technology and programming today. But right now we're still on somewhat of a parallel path where we'll bring the IT team into the conversations and say, number one, analyze, is this beyond what our capabilities and abilities are to produce in terms of a user interface today? And for the most part, they're saying, yes, this vendor has a far more advanced thing than what we would be able to program or bring online in the next 3 to 6 months. So that helps us to make that decision. As far as having an internal standard for model drift, we do not have that today. It's a great question. I think we have internal standards for, what are we inspecting and what are we not inspecting, and what our tolerances are for our product and our design, and we're using those as we design our projects and our vision systems. But not for model drift yet.
Yeah, maybe you guys mentioned this earlier. What part of the organization you guys are on, the technology side or business operational side? What's your roles directly?
Yes, on the IT side.
IT side, okay.
But with an engineering focus.
Got it. Thank you.
We have just a few moments left. Any last questions from the audience you want to jump in here?
Yeah. I'm Chirag. So I have a question around the team. What kind of team, like the structure of the team you have to make it successful? Like, do you have a data science team in house, or you have computer vision experts who can help you figure it out? Like, okay, because out there you have like hundreds of vendors, as you mentioned, right? Who can come and bombard you with all the information they have, and they'll say, "Oh, it's successful." So do you have people in house who help you navigate through these vendors and say that, okay, yes, maybe these are the vendors who are good, more successful, or maybe their technology looks better? So what kind of team structure you have to make these kind of products successful?
Okay, let me try to answer that. We are a very, very small team, and we've started this journey around 18 months ago. At the moment, those projects are typically executed by regional and local manufacturing, engineering, and quality teams. So we don't really have the dedicated resources in place now. So the people who have this vision are Joe and I. We are currently in the process of seeking the approval for this, at least one dedicated person who owns the entire approach. The standardization question was relatively simple because we asked around what are the preferred regional preferred vision system suppliers, and we were pretty surprised that they all mentioned the same. Okay, they all mentioned the same supplier who makes the hardware and the software. So they offer complete systems, and they have a global footprint. So then we said, why don't we try to cover all our vision system needs with that supplier? And the team generally said, yeah, let's try and do that. This was the approach number 2. And lately we have learned, well, we should probably be a little bit more open and come to a toolkit. So we would still recommend using the camera, hard and software, including the lighting, from companies who can provide one package globally. There are a couple of big ones, right? Just to name 2, you have Keyence, you have Cognex, and there are a few more. They can provide a system, and they also provide the software. However, we find sometimes the projects are so complex that you need integrators who can go beyond the capabilities. And there we are currently working to identify who we should partner with. And we might end up with a handful. Maybe it's 2, maybe 3, maybe 5 in the end, preferred partners on a global level, on a regional level. And so far, the teams are supporting this pretty well. There is not a lot of noise. And as soon as we have this dedicated global lead for vision systems in place, we will be able to drive this strategy forward. We have done some bits and pieces out of all 5 stages that we presented. Are we perfect? No. I think once we have that person in place, we'll need to go back and see in which of the phases we have some gaps to really successfully implement this. But we are aware, we are sharing this at an early stage, but memory is still fresh.
Thank you. Thanks for answering, Tobias, because we are also always have these kind of questions, because we have IT team. Within the IT team, we have a data science team. We have a big computer vision team as well. And we always try, struggle, or I would say not struggle, but maybe always in the situation where should we go all outsource, buy versus make decisions. So that's something, always challenging. So thank you for sharing your experience.
One additional comment maybe to that: when you have standardized all the tool sets, so you have your hardware, your cameras, and you have your software, most of the programming is actually only parameters. So it's settings in the software, and then it becomes very easy to transfer a model from one location to another if they both use the same hard and software. It's only sharing a configuration like a PLC program. If you mount the camera in the same distance and angle, then the same program becomes usable. This only works if you're using the same camera with the same lighting and the same software. You can copy the program. This is the standardization and the scalability factor that we realize the rollout can be accelerated significantly if we all use the same basic building blocks.
Absolutely, very right. Thank you for sharing.
Thank you.
Thank you. Thank you for the questions. And Tobias and Joe, thank you for the presentation. I know you've said that you're early in this process. So I'd like to leave an open invitation up for you to come back when you feel a little bit further along even, and let's see if some of the lessons learned have changed, or if your thinking has changed, or your approach, if you move on to approach number, I think 5, or how it might evolve as you're going forward. So I want to leave that invitation out there for you. And for everyone else on the call, I want to remind you that we'll be back for our next meeting on May the 15th, as you'll see on the screen right now. So that is our next call, which is I have someone lined up, but I'm not able to give you the full details of that at this point. But mark your calendars now. May 15th is our next call, and you'll get emails about this and other information. Upcoming plant tours again. Schneider is as far as I am aware, sold out, but you can get on the wait list for that. And United Scrap Metal Tour has just opened, but it will sell out as well, like all of our tours do. So please register for those. And one last mention of Rethink. As I said at the top of the call, this event sells out every year. The hotels sell out. You want to get in there and get that registration as soon as possible, because there's no better opportunity to pick the brains of other people, share what you're doing, and learn from each other as we rethink digital transformation in manufacturing. So thank you again to Joe and Tobias, and we will see everyone back here for our next call in May. So have a great day, everyone.
All right. Thank you, guys. Excellent.